Good morning everyone. So hari ni kita akan belajar the second part of group 4A. So previously kita dah belajar pasal a little bit about the general properties and macam mana apa kegunaan of group 4A elements, and then we focus on carbon and their compounds. So today kita akan buat the second part of it before the next class baru kita akan belajar the final part, which is on tin and lead. So today we will be learning about silicon, which I'm sure many dah biasa dengar. Okay, so silicon is actually the second most abundant element on earth. So nak teka tak apa the first one? Okay, so I know this is not a synchronous class, no one will answer me. So it's the second most abundant, while the first one is actually oxygen. So that's very normal lah. Sebab a lot of compounds contain oxygen. So naturally they also don't exist as the, tak adalah awak boleh rata-rata jumpa them as silicon, pure silicon. So they exist in their compounds. The most common one is in the oxide form, silica or silicon dioxide. Dia ada dalam sand, quartz, flint and agate, semua gambar-gambar kat sini. Or as silicate substances. So apa tu silicate? They will be one of the compounds that we will be learning also. Oh, another thing in this video, so I won't be opening camera sebab saya sebenarnya nak buka, but my internet is very weak that I cannot. I'm afraid that it will be unstable. So sorry, this tak the video saya. Tapi tak apa. Soon we will do face to face. So then you'll get to see me a lot. Okay, so how do we extract the silicon out of from dia punya compound? So the first way is by reducing silica, which is from sand, by using coke. So coke kat sini maksud saya bukan coke air tu walaupun house base ni ada coke tu, bukan It is actually coal lah. Maksudnya dia macam dari bentuk carbon, dia macam bentuk biasanya cubes and warna hitam. Okay, so this have to be done in an electric furnace, maknanya perlu pemanasan lah. Okay, so if we have the silica with the coke, you will get the silicon with a side product of carbon monoxide. However, dalam proses ni, we have to ensure that silica berlebihan. Okay, this is to prevent the formation of silicon carbide. So kalau silica dalam keadaan biasa, selain daripada this normal reaction, you will also get this reaction where silica with carbon, you will get silicon carbide or carborundum. Kita ada sebut masa at the previous class with the side product of carbon monoxide. So if we have excess silica, the silicon carbide produced akan terus react with the silica to get the silicon juga. So which is why it is important to have excess silica in this process. However, kalau you want really pure silicon, we can do this, which is a two-step process. So we start with silicon tetrachloride by using sodium. Okay, so in this process, silicon tetrachloride dengan sodium, you will get the silicon with a side product of a metal halide. So dalam case ni is the sodium chloride lah. So the sodium chloride form can be removed by washing with hydrochloric acid. However, dia mungkin ada impurity sikit lagi. So kalau kita nak dapat pure, the purest that if you use this process, you actually can get 99.9999% of purity. Sangat-sangat tinggi. So we will use a heating rod. So what happened is the silicon that you obtain here is refined by heating the rod here, rod kat sini, from one end, maknanya daripada atas dia akan heating coil tu akan bergerak ke bawah, okay, and the impurity will move simultaneously with the heat. Dia akan ikutlah the heat, okay. Lepas dia akan sampai bawah and then they will cut off the impurities part. Dia boleh potong. So apa yang tinggal is just ultra pure silicon. Okay, let's look at some characteristics of silicon. Although dia bukan fully metal, it's a metalloid, okay. So it is actually, dia dalam bentuk crystal, it has a metallic luster. So dia macam berkilat-kilat macam ni, but it's not fully warna silver. Dia grey sikit lah. Dia macam grey sikit color dia macam ni, okay. Tapi dia berkilat-kilat lah if it's pure form. So it has a diamond lattice, okay. Maknanya dia punya formation tu is a diamond lattice, which is why it has a very high melting point, around 1414 degrees Celsius. It is generally inert, tapi can be attacked by halogen. Okay, so halogens such as fluorine contohnya. So it does not dissolve in any acid except hydrofluoric acid. Sekejap lagi masa kita masuk ke the oxide compound, I will stress on kenapa kita perlu tahu bila ada benda gelas kita tak boleh guna apa-apa yang kita tak boleh guna gelas untuk handle hydrofluoric acid. So with silicon reacts with hydrofluoric acid, you will get the hexafluorosilicic acid with the release of hydrogen. Untuk asid, dia hanya akan react dengan hydrofluoric acid, but with base, it dissolve in most base, such as sodium hydroxide ke apa, to get the silicate ion and also the silicate anion with release of hydrogen. So we are, once again, like usual, we are going to be looking at the compounds of silicon. So for silicon, kita ada 4 compounds that we will see. One is the oxide, okay, so which is silica yang kita ada sebut tadi. Second is the silicate. Kita akan tengok sikit aluminium silicate, silicate glass and so on. Then kita akan tengok silicon, which is something yang kita banyak guna juga. And finally the halide. So let's start with the oxide. Okay, so for the oxide of silicon yang kita nak fokuskan sini is the most important one, which is silicon dioxide, SiO2, or known as silica. So kalau perasan, saya memang akan sebut silica lah sebab saya dah biasa. So ingat tak silica gel yang kita guna? Yes, this is the SiO2. Okay, so structurally it actually exists as a polymeric tetrahedral SiO2. So dia memang Si dengan 2 O, tapi sebenarnya structure dia ada besar macam ni. Okay, it is a polymeric tetrahedral macam ni yang bersambung-sambung-sambung. Okay, so even though it is a covalent macromolecule, okay, with the formation of polymer, maknanya dalam polymer besar macam ni, dia ada 50% ionic characteristic. Why? Because of the big electronegativity difference between silicon and oxygen. So oxygen we know is one of the most electronegative element, only second after fluorine. So while silica hanya 1.8. So due to the big electronegativity difference, dia ada around 50% ionic characteristic. However, as a whole, once again, it is a covalent compound. So how do we prepare silica? So there are a few ways. So the first way is you do it using the hydrolysis of silicon tetrachloride. So bila kita ada SiCl4 with water, hydrolysis kan, maknanya kita campur dengan air, you will get hydrochloric acid with one of the silicon acid of silicon, okay, which di yang ni H4SiO4 is known as silicic acid. So bila kita dah dapat the acid, in order to get the silica, we need to heat it, kena panaskan to 1270 Kelvin in order to get the silica. So the second way pun sama, dapat acid dan panaskan, which is the acidification of water glass. So apa itu water glass? So from here on, awak akan selalu dengar pasal water glass. So water glass is actually ni, sodium silicate. So sodium silicate bila larut dengan air, kita akan dapat water glass, which is why orang sebut bila tengok sodium silicate, sometimes people will say sodium silicate, sometimes people will just use water glass. So kena ingat, when we talk about water glass je, it is referring to Na2SiO3. Aduh. So the acidification, maknanya kita perlukan an acid. So dalam case ni is kita guna hydrochloric acid. You will get the side product of sodium chloride and also one of the acid, ni acid lain pula sikit, H2SiO3 or 3. You don't have to hafal nama dia, saya just letak for your information. Okay, so this is known as metasilicic acid. Once again, nak dapatkan dia cara yang sama dengan cara yang pertama ni. You heat it to the same temperature and you will get the oxide, which is the silica. So let's look at some properties of silica. So silica at low temperature, it is inert. Maknanya kalau dalam suhu biasa, suhu rendah, dia macam lengai je. However, it can become very reactive at elevated temperature. Bila dipanaskan, dia sangat reaktif. Okay, and it becomes strongly acidic oxide at elevated temperature. And once again, benda ni saya nak tekankan, sama macam silicon, the element itself. So it only dissolve in hydrofluoric acid. So dengan acid lain, dia tak akan dissolve kecuali kalau hydrofluoric acid. So kalau kita ada silica, kita reaktkan dengan hydrofluoric acid, dia akan larut dan akan bentuk H2SiF6, or known as hexafluorosilicic acid, one of the most popular acid of silicon. Okay, and with the release of water. So apa yang penting kat sini? So in lab, we have all kinds of acid. Okay, so we have hydrochloric acid, we have nitric acid, sulfuric acid. All this tak ada masalah. Sebab apa? When we want to deal with that, we can use normal glass apparatus. Most of the apparatus kat lab memang made out of glass. So we can use, you can just use normal beaker ke apa untuk handle dia. Nak measure, we can use a measuring cylinder. However, a very important fact, if we are dealing with hydrofluoric acid, never ever use anything glass. Sebab dalam glass ada silicon compound silica. So kalau kita guna dia, contohnya kalau kita ambil, kita nak measure kan, kita ambil the hydrofluoric acid from dia punya botol, kita tuang ke dalam a beaker, okay, a glass beaker, dia akan terus lubangkan beaker and it will be very dangerous. Satu, dia dah rosakkan the beaker. Lepas tu dia terjatuh macam tu, and hydrofluoric acid is very corrosive, so it's very dangerous. Which is why, if you see, kalau kat dalam lab, hydrofluoric acid memang dia simpan dalam a very thick plastic bottle and siap lepas tu akan ada tray plastik kat bawah supaya dia tak bocor. Sebab bayangkan kalau dia bocor and terkena glass bottle lain kat dalam tu, dia akan larutkan, and can you imagine the horror? Okay, which is why kena ingat, hydrofluoric acid, if you want to deal with it, kena cari plastic beaker ke apa. Never ever use anything glass. Okay, enough about acid, kita tengok alkali pula. So, the same dengan dia punya elemen juga, it dissolve in alkali. So, acid dia hanya dengan hydrofluoric acid, tapi for alkali, it dissolve in almost all alkali. So, kalau let's say, in the case here, kita ambil sodium hydroxide with silica, you will get, once again, the water glass with water. Okay, so, sebab kita guna sodium kat sini kan, so kita dapatlah sodium silicate. Okay, so itu sahaja for now pasal dioxide. Nanti saya akan buat sedikit perbandingan antara silika dengan silikon. Okay, so let's look at the second compound, silicate, yang ada quite a few. Inilah yang akan ada kaitan dengan zeolite, ada kaitan dengan glass and everything. Okay, so apa itu silicate? So silicate in the form of anion is actually as SiO4 4-. So macam mana kita dapat? So it is usually when we have silica, the oxide, kita campurkan either metal dengan metal oxide lain, metal sulfate or metal carbonate. So one of the most popular silicate yang ada is sodium silicate, the water glass tadi tu, which is Na2SiO3. So sodium silicate, you obtain it by reacting silica with sodium carbonate kan, dengan metal carbonate kan. So you get sodium silicate with the side product of carbon dioxide. So sodium silicate, bila we dissolve in water, you will get water glass. Which is why kita, like what I said, bila kita nampak je sodium silicate, kita cakap dia water glass. So in the form of structure, sebenarnya it is a very big polymorph, okay, SiO4 punya, which contain tetrahedral SiO4 through the SiO-Si bond. So sebenarnya, kat sini, kalau kalian tengok, every silicon has exactly 4 oxygen atom and every oxygen has exactly 2 silicon. So satu Si dia akan terikat dengan 4 O, and setiap satu O tu akan terikat dengan 2 Si. So inilah dia punya network macam tu. So sebab ni SiO-Si bond. So the Si in the center is linked to 4 oxygen atom covalently. Tapi once again, it's a big molecule yang besar macam ni lah. Bukan just satu unit je. It is a unit berulang macam tu. Okay, so this one is just for you to know, tak payah hafal ke apa, but just to tell you what kind of minerals yang ada silicate kat dalam dia. Okay, some of it kita ada sentuh sikit bila kita tengok all the gems kan. So another type of gem ni, emerald, which I believe even dalam dia macam permata yang kat cincin yang banyak lelaki pakai juga, if I'm not wrong, the green very beautiful. So it is a green beryl. So yang ada kat dalam dia ada beryllium, ada aluminium, silicate of course. Okay, warna hijau dia comes from the 2% of the chromium 3+ ion. Okay, so kat dalam dia ada anion ni. So diorang semua ada silicate anion yang lain-lain yang disusun. So yang dalam case emerald is Si6O18 12-. While there's also something called diopside. Okay, pun dia ada calcium, magnesium and also silicate kat dalam. Tapi dia punya silicate is Si2O6 4- type. So nampak tak, dia repeating unit tapi dalam susunan lain-lain. So kita ada juga asbestos, which is no longer used much because it's dangerous. It's a fibrous material. Okay, it's a chain structure double-stranded anion, and anion dia ialah disilicate, Si4O11 6-. Okay, so ni susunan dia. And we also have mica, which is cleaved into thin sheet because of its 2-dimensional layer structure. So anion dia is actually Si4O10 4-. Okay, so diorang sama semua ni ada silicate tapi lain-lain dia punya repeating unit and susunan dia lain-lain. So I actually find it very interesting. Dia hanya disusun lain-lain, awak akan dapat benda lain. Contohnya ada yang dapat fibrous, ada yang dapat sheets, ada yang dapat bentuk emerald semua. So it's very interesting. So that is about the mineral. So let's look at something, a silicate compound yang sangat penting sebab dia adalah terbentuk zeolite, which is known as aluminosilicate. So aluminosilicate is a 3-dimensional silicate. So dia 3 dimensi lah. Dia bukan just sheet ke apa. Dia macam akan ada siap ada bentuk, siap ada pores, siap ada turus, semua macam tu. Okay. So it occurs when aluminium substitute silicon in the silicate framework. So tadi kan dia SiO4 kan, maknanya dia akan ada Al juga kat dalam dia. Substitute, lepas tu substitute kan ada Si juga, dia berselang-seli sikit macam tu. So sebab macam tu dia punya framework sebenarnya as a whole is a negatively charged framework. So kalau kita kira SiO4 dengan AlO4, so kena take note kat sini, kalau ingat kat sini charge dia ialah -1 sebab kalau kita kira balik kita akan dapat that the overall charge is -1. It is usually negatively charged. And kita tahu kalau negatively charged, you always have to have an ion untuk seimbangkan dia punya charge in order to make it stable. So which is why aluminosilicate are always balanced by cations. Okay, cation apa? Okay, it can be from group 1A or 2A, for example, sodium, potassium, calcium or magnesium. Or dia boleh transition metals such as iron 3+. So, diorang akan di luar framework untuk imbangkan dia supaya dia stable. So, what are the type of aluminosilicate yang ada? So, there are a few type. Kat sini kita letak 2 type, where the second one yang the penting one. So the first one, we have feldspar, which ada bentuk lain-lain. So ini rupa feldspar. We have autoclaves with ada potassium and aluminosilicate kat dalam juga. Once again, ni aluminosilicate ini yang untuk imbangkan dia punya charge yang kat luar. So this is known as albite. Okay. So itu feldspar. Tapi the one that I want to focus on is zeolite. Sebab dia ada banyak kegunaan. Okay. In fact, I did some of it during my masters also. Sebab I'm in the field of heterogeneous catalyst lah. So, zeolite is a hydrated aluminosilicate crystal. Dia ada open structure framework, open structure which contain cages, channel or pores of regular dimension. So, contoh ni lah, dia mungkin ada pore yang regular, macam ni. Ke dia ada susunan yang cantik macam ni, yang regular, okay? So, dia regular, dia akan ada channels, pores and everything. So, generally, ini formula dia. Okay? So, kena tengok dia punya yang ada brackets yang square ni and also ni. So the bracket yang kat dalam bracket tu memang sentiasa ada silika dengan alumina is the aluminosilicate framework. Okay. So sebab dia negatively charged, once again dia perlu ada cation kat luar untuk balancekan dia punya framework. And while kat luar ni, kalau tengok perkataan hydrated ni, sentiasa kat dalam dia punya pores will be water molecules occupying the pores or channel or cages kat dalam dia. Dia kat luar dan dia is only physically bonded to it. So dalam keadaan biasa memang sentiasa ada water tu, tapi it can be removed by heating because it's only physically bonded to it. So dalamnya memang ada hydrated water lah, tapi boleh di remove by heating. So kenapa zeolite begitu special? One of the most important characteristic is dia boleh jadi molecular sieve. So as we mentioned just now, dia ada regular size of pores and channel. So dia punya pores tu, maknanya dia punya liang tu kan, pores dia tu kan, mungkin biasanya size dia lah antara 4 to 12 angstrom. Okay, so 4 to 12 angstrom is 0.4 to 1.2 nanometer. And ini adalah size molecules. So awak bayangkan, macam contoh ni bila kita nak sieve tepung, kita guna dia ayak tu kan. So kita letak tepung kita, yang cukup kecil akan lepas, yang kekotoran semua akan tinggal. So this is the same concept, tapi bayangkan molekul. So kalau kita nak buat certain reaction yang kita hanya nak molekul kecil ke molekul of certain size, kita guna zeolite. So hanya certain saja yang boleh pas, yang kita tak nak pun yang tak lepas. Which is why it is known as a molecular sieve. Dia sieve apa? Dia sieve molecules. So instead of sieve yang kita guna, ayak kita guna biasa tu, ni dia guna zeolite as molecules punya sieve. So how fascinating, right? Okay, another very good thing is, tadi kan cakap zeolite tu is negatively charged and dia sentiasa kena ada cation untuk balance dia punya charge. Sebab negatif sahaja tak stable kan, so kita kena something positive untuk neutralkan dia. So the cation, dia boleh ditukar-tukar, which is why it can be ions exchange. And this is very important in water softening. So saya ambil contoh ni, just contoh yang gambar macam mana zeolite digunakan. So hard water adalah bila benda yang mengandungi kalsium dan magnesium kat dalam. So kalau awak perasan kat air pipe awak yang putih-putih, yang termendak-mendak kat dalam awak punya, let's say tangki air, that is caused by hard water, which yang ada kalsium, magnesium. So dia tak bagus for your pipes and boleh korot, boleh susah nak dibuang lah. Okay, sebab dia akan stick. So what happen is kita buat ion exchange. So kalau let's say lah zeolite tu, dia punya, zeolite ni sekarang dia letak sodium kat sini kan. Kita masukkan dia adalah dia punya cation ialah sodium. Okay, so sodium ni dia akan bertukar partner dengan the calcium atau magnesium. Okay, sampai awak dapat sodium chloride atau di sodium sulfate. Dan ini tak ada masalah. Dia adalah soft water, ada sodium punya salt. It's not hard water. So while yang ni kalsium tadi tu dah berikat dengan di zeolite or di magnesium dah berikat dengan zeolite 2+. Okay, so sekarang dia boleh mendakkan and boleh dibuang as a solid. So which is why kita dah remove the hard water. Okay, so ingat hard water biasanya ada calcium, magnesium and a few others lah. Sodium bukan sodium chloride, sodium sulfate is not hard water. So tak ada masalah kalau dalam air kita. Okay, another characteristic. Okay, this is just nak tunjuk contoh lah. If you learn about catalytic chemistry, kalau when you're in your final year, I think this is one of the subject yang akan di-offer. I'm not sure akan di-offer pada awak semua ke tak. Okay. Okay, one of it is that kalau dia punya cation tu kita tukarkan dengan ni H+, okay, sebab this is also a cation, so it will become a very strong acidic zeolite, acidic solid acid catalyst, okay, which is why it is used as heterogeneous catalyst. So saya just nak terangkan apa maksud heterogeneous catalyst, because this is actually my field. So bayangkan kalau kita punya reaction adalah liquid dengan liquid, bila kita masukkan a solid punya catalyst dalam, maknanya di dalam phase yang lain dengan dia punya reaction, so it is named as heterogeneous catalyst. Okay, so it is very useful in a lot of organic reaction. Why? Sebab dia ada Brewster and Lewis acid, which is very useful. Tak adalah saya suruh awak fahamkan, but this is just to tell you lah. Sebab of the strong acidity, it can become a very good catalyst. Okay, ada pelbagai-bagai jenis framework for zeolite. Ada pelbagai jenis tu. So saya ambil contoh kat sini. This is a sodalite, salah satu jenis zeolite. Okay. So kalau kat sini dia sebenarnya adalah this building unit yang berulang-ulang-ulang. Okay. So this is the building unit. So it is joined by the 4 member. Maknanya ada 4 member. Mana pen saya? 1, 2, 3, 4. Dia join macam ni. Okay. So bila join macam ni, dia akan ada juga selain daripada pores yang ada masing-masing, dia pun akan ada beta pores. Maknanya bila 4 join tu dia ada lubang kat tengah ni, pores dia. And this pore is around 2.8 Armstrong. So 0.28 nanometer. So ni bagus jugalah kalau kita nak tengok, kita nak yang kecil kan. So this is how they form the pores. So okay, so zeolite memang ada pelbagai-bagai jenis. Okay, you can synthesize other natural occurring zeolite juga. So we can use different zeolite for different functions. So these are among some of the zeolite yang digunakan for different functions. So for example, zeolite A, zeolite X, zeolite Y, and clinotillolite, comel nama, and modernite is widely used as ion exchanger. So dia ada masukkan sikit as water softener in detergent. Sebab bila kita basuh baju, the air yang kita masukkan dalam the washing machine mungkin akan ada hard water. While zeolite A, X and carbazite is widely used as molecular sieve and absorbent. Dia bagus untuk serap benda, which is why it is widely used to separate gases of different size in industrial process, dalam gas chromatography GC, and of course as a drying agent sebab dia senang nak menyerap air. While zeolite Y, ZSM5 and beta, something yang saya ada buat masa master saya dulu, is widely used in heterogeneous catalyst. Tadi yang saya cakap tu lah acidity dia. So dia sangat bagus dalam petroleum industry. Why? Because it can be used in hydrocarbon cracking, isomerization, alkylation, and also Frederick-Cow acylation. Okay, so these are among some of the organic reaction lah, okay, yang di widely used. So which is why kalau even in the petroleum industry sekarang memang guna zeolite, memang sampai sekarang they still use zeolite. So enough about zeolite. Also, sorry, sikit lagi pasal zeolite. Saya just nak tunjuk je. Zeolite ada berbagai-bagai lain dan berbagai-bagai bentuk. Okay, so contohnya zeolite A. Okay, zeolite A. Kita ada ZSM5. Kita ada zeolite A tapi bentuk lain sikit. Dan kita ada zeolite Y. Semuanya Adalah zeolite tapi susunan lain-lain. Maknanya dia punya unit tu berulang-ulang sampai dia dapat pore size lain-lain dan rupa lain-lain. Okay. So silika tadi kita dah sebut pasal the silicate glass. Kita dah sebut pasal aluminium silicate. Which yang pentingnya the silika the zeolite. So sekarang pasal gelas pula. So bila kita sebut je pasal glass, we know that there's always a silicon kat dalam, and in this case silicate lah. So it is obtained bila kita ambil sand, kita campur sand yang ada SiO2, kita campurkan dengan metal silicate, aluminium silicate or borosilicate, and you will get the glass. So some important characteristic of glass, kena ingat glass, okay, cermin yang kita guna biasanya tu, it is not, bukan cermin yang untuk tengok diri, okay. So it is not a true solid, okay. Dia sebenarnya bukan pepejal. It is actually a super cool liquid, maknanya disejukkan mendadak sampai dia jadi sangat-sangat likat, high viscosity, that the free flow of liquid is not possible. And because it is not solid, okay, it has no melting point and it is amorphous, okay, it is not a solid. However, kalau kita panaskan dia, it will start to soften, it will turn a bit semi-solid, finally become a clear liquid. Suhu yang sangat tinggi lah, okay. And dia punya feature pun lebih kurang macam silika and also the silicon. It is inert by most chemical but can be attacked by halogen, which is the fluorine, hydrofluoric acid, which is hydrofluoric acid, and also alkali. So glass, kita ada berbagai jenis glass, and sekarang let's look at soda glass, which is glass bottle yang kita biasa guna. So how do we obtain soda glass? Soda glass is actually a mixture of calcium silicate and also sodium silicate. So macam mana kita dapat calcium silicate dengan sodium silicate? So senang je, kita ambil silika, kita campur dengan silika campur calcium carbonate, you will get calcium silicate. Silika, kita campurkan dengan sodium carbonate, you will get sodium silicate. So dua ni bila campur, you will get the sodium glass. Atau the overall lah, kita terus buat je. Kalau kita ada calcium carbonate dengan sodium carbonate, dengan silika, which is the sand, you will get the soda glass. Okay, so soda glass ni depends on apa transition metal kat dalam, dia mungkin akan berlain-lain warna. So botol-botol warna yang kita nampak, kenapa dia berlain-lain warna is due to memang dia adalah sodium glass, ada calcium silicate dengan sodium silicate, tapi warna dia datang daripada di transition metal ion yang ada kat dalam. Contohnya, kalau we have some iron 3+, it will be yellow. 2+, it will be green. Chromium 3+, it will also be green. A little bit of different. So kalau kita ada manganese 2+, it will be violet. Cobalt 2+, blue. Well, copper ada dua oxidation number that is commonly available. So if it's 1+, you will get red. But if it's 2+, it will be a peacock blue. So cantik-cantik lah kan, different glasses. So ni contoh lah, saya just nak tunjuk. Ada gelas apa, dia warna apa. So cantik-cantik all these soda glasses. Kalau kita masukkan transition metal yang lain-lain, you will get different coloured glass. So ni awak boleh search je pun jumpa contohnya yang tadi cakap. Kan, iron 2+ ke iron 3+ akan dapat lain. Kalau kita masukkan sulfur sini pun akan lain. So tadi mana? Chromium, you will get the green. Copper, this is the peacock blue lah kalau 2+. 1+ dia ada letak tak kat sini? Tak ada 1+ tak ada. Okay, so different type you will get different. So it's very interesting. Sangat cantik lah. Okay, so that is soda glass. However, there's also many different types of glasses. Okay, glass bukan ada satu jenis je, bukan botol biasanya. Berbagai-bagai jenis and semuanya ada silicate kat dalam. So let's look at the type of silicate. I'm just going to go through for you to learn. So contohnya kita ada soft glass biasa, okay, botol air yang biasa. Okay, it's an ordinary solar line. Dia senang nak fuse dengan, so easily fuse, kita senang nak cantumkan dia, which is used for making bottles and window glasses. So this is known as soft glass. There's also hard glasses, maknanya yang keras sikit. This is potash lime glass. Okay, so dia ada potassium kat dalam biasanya. Okay, it is used for glass apparatus. Sebab kenapa? It is resistant to chemical and sangat susah nak cairkan dia. Kena suhu yang sangat tinggi. Which is why hard glass is used for chemical apparatus, glass apparatus. Yang kat dalam lab lah. We also have flint glass. Okay, which is a lead potash lime glass with high refractivity. So dia senang sebab of high refractivity dia digunakan untuk buat prism, lenses and optical devices. We also have something known as the Jena glass. Kalau jumpa kadang-kadang ada jual juga yang orang guna untuk buat glass punya kettle sebab dia kena dipanaskan kan. So it's actually zinc barium borosilicate glass. Sebab dia ada low thermal expansion, maknanya bila kita panaskan dia tak akan mengembang. So which is what dia susah nak mengembang. So it is used for heat shock resistant apparatus. So contoh yang saya letak kat sini, this is a kettle lah. Awak boleh panaskan dia, letak untuk panaskan air. We also have Pyrex or Corning glass. Okay, so it is actually sodium aluminium borosilicate, similar to Jenna glass pun, dia pun heat resistant. We also have something called Crookes glass yang boleh cut off UV ray. So dalam dia is actually calcium oxide yang ada replaced by lead oxide, barium oxide, zinc oxide or magnesium oxide. We also have quart glass. So ini banyak kita gunakan untuk quart glass, kita guna juga as a sample holder for different type of instruments such as ultraviolet visible spectrophotometer. So dia adalah pure silica that does not crack even if red hot vessel is plunged straight into water. We also have something called ground glass. Okay, it is a soft glass. The surface has been grounded by emery or turpentine. And ini, this reinforced glass pun sangat penting. Okay, so apa yang ni? It is a network of wires embedded in it. Maknanya in between glasses tu ada wire kat dalam tu. Why? So that it does not shatter easily. So the safety or shatterproof glass is obtained by joining 2 or more layers with a transparent adhesive layer then cementing them under pressure. So kita masukkan dia, in between dia ada wire, lepas tu kita campurkan. Kenapa dia bagus? So contohnya bangunan ke apa, bila kita pecahkan, instead of dia pecah jadi beribu-ribu step, beribu-ribu gelas kecil and disenang lukakan orang, dia tak akan, dia just akan crack tapi dia tak akan terpecah, terjatuh merata-rata. Which is why this is very good. Even contohnya kita punya glass window sekarang pun banyak yang ada guna glass macam ni. Bila kita kena pecah, kena batu ke apa, dia takkan terus pecah and letak merata-rata sampai kita luka. Dia memang dah pecah tapi dia akan kekal kat situ because it has been reinforced. So this is for safety reason lah. Okay, so itu mengenai silikit banyak sikit So kalau sekarang macam rasa, aduh banyaknya, you can take a short break, no problem. Okay, so kita baru 31 minit take a short break and then kita belajar pasal silikon and halide. Saya akan teruskan, awak boleh je pause video tu. So let's learn about silikon, pun something yang kita banyak dengar. So silikon, apa yang bila kita tengok silikon is organosilicon compound. So dalam dia ada organic part and ada silicon part kat dalam. Having heterocatenated SiO-Si bond in the form of chain, ring or branches. Okay, so dalam dia akan ada SiO-Si with couplekan dengan an alkyl or aryl, which is the organic compound dia lah. Okay, which is bonded to, as I contohnya CH3 ke apa, bonded to the Si atom. Okay, so preparation dia ada 2 step. Okay, dia sentiasa start dengan dia punya starting compound is an alkyl or aryl silicon halide. Kita first kena hydrolysekan dia, followed by condensation. So jom kita belajar jenis silikon yang ada and macam mana kita nak dapatkan. So ni kita buat sama-sama macam mana nak buat sebab ini antara soalan popular juga. So there are 3 types of silicones. Okay, so the first one, dia depends on the initial type of alkyl or aryl silicon halide. So R kat sini boleh berbagai-bagai jenis. It can be CH3. It can be CH3, CH4 yang panjang sikit ke apa. Okay, it is the organic part of it. So disilicon kita akan dapat if the starting material is R3SiX. So yang penting kat sini, saya nak awak fokuskan kat, okay, ingat Si sentiasa boleh berikat dengan 4 benda. So dalam case ni, kalau dia ada 1X saja, satu je halide, kita akan dapat disilicon. Okay, so maknanya kat sini dia ada R dengan 1X. Why? Bila tu sebab the first step, dia sentiasa kena go through hydrolysis followed by condensation. So in the first step, which is the hydrolysis, the X will be replaced by OH. Okay, so OH. Okay, so ini akan pergi couple dengan X, so ini akan masuk balik. So that's why you will get this form. Okay, so X tadi tu dah diganti oleh OH. So from there on, kita akan lalui hydrolysis, condensation. Condensation tadi kita masukkan OH, sekarang kita nak keluarkan air keluar. Okay, so kalau kita ada 2 of this one, these 2 molecule kita letak side by side like this. Okay, so a molecule of water akan dikeluarkan. Okay, untuk dapat disilicon. Disilicon maknanya ada 2 silikon. So dia akan sentiasa dihubungi by SiO, SiR3. with a side product of water lah sebab kita keluarkan water. So, jom kita cuba buat sama-sama. Okay, kenapa saya cakap this is a very popular question dan you have to understand. So, starting material kita kalau dia adalah ada satu je, satu je highlight. Dia ada rubber kat sini. Tak apa. Sorry. Okay, so kalau dia ada satu X sahaja, so kita ada R, R. Saya lagi suka kalau awak lukiskan keluar rather than awak buat tadi tu yang macam tadi dia just tulis R3SIX. Kalau kita lukiskan keluar macam ni, it's easier to print. So, dia plus HOH, kita akan dapat, so once again, X tu akan dikeluarkan. So, kita akan dapat SI, R tak keluar R kekal je kat situ the organic part, OH, macam ni, plus HX. So, this is the reaction. So, the next step which is the condensation. So, dia dah hydrolysis, next is condensation. So, condensation, kita ambil dua molekul yang the product tadi tu, kita letak sebelah-sebelah. So, SI, sekejap ya, OH, okay. So, kita pluskan dengan satu lagi molekul yang macam ni, okay. Okay, saya tahu macam kenapalah saya, tapi this is important. And when you show it, it's important that awak kena tunjuk mana air tu keluar sebab kita nak condensation. So, barulah awak akan dapat the disilicon which is R, SI, O, SI, R, ni pun R, ni pun ada R, R, plus jangan lupa H2O. Ada tak cukup tempat. Okay, so please pause and try and buat sama macam ni. It's important that you understand. So this is the first one. Ada dua jenis lagi silikon. So let's look at the second one, which is known as the chain. Chain so dia rantai lah, so dia memanjang. Tadi dia dua je silikon. So ni bayangkan SiO, 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 SiO panjang. So this happen when the starting material ada dua X. So ingat Si sentiasa berikatan dengan 4 benda. So kalau dia 2X, kena ada 2R jugalah. Okay? And you need 2 molecules of water untuk buat tu. So, awak bayangkan So, sekarang R. Kalau bayangkan dengan 2H2O, maknanya 2X ni akan jadi SiOH. Aduh, tak cukup tempat. OH, R. Plus H2HX lah. Sebab keluar. So, itu the condensation. So, once again, bila kita dah dapat ni, macam mana dapat chain kalau kita letak dia sebelah-sebelah. Okay, once again, condensation keluarkan air. Okay, so, bayangkan, kita letak banyak-banyak unit. Kat sini pun kita letak lagi. So, air boleh keluar daripada kanan, kiri, dekat semua. So, sampai kita dapat jadi the chain. So, penting untuk kita tunjuk mana water dia tu. So, once again, awak boleh cuba try buat. Okay, cuba pause and buat sendiri. So, start dengan di hydrolysis. Si. So, ingat X tu akan digantikan dengan water. Okay. So, water dia dengan OH. Sorry. Okay. So, daripada sini, kita letak sebelah-sebelah dia untuk dapat kita buat dia punya condensation pula. So, start dengan hydrolysis. Kita buat. So, kita boleh letak Si. Sebenarnya dia boleh letak banyak-banyak bukan satu. So, kita kena highlightkan mana water dia dapat. So, barulah kita dapat the chain one which is, ingat dia punya ikatan sentiasa SiOSI. OSI, OSI. Awak boleh teruskan je. Atau awak just fill in kan dia punya R ke O, H ke apa benda. Sampailah dia dapat chain yang macam slide tadi ni tulis. Okay? So, that's how you get. So, itu chain, the second type. So, the second type is the X ada 2. Tadi X ada 1. So, sekarang kita ada branch pula. Konsep yang sama, tapi dia punya itu ada 3 halide dia. Okay, so dia sama dia, kita perlukan 3 molekul water, semua X tu akan diganti. So, bila dia 3 OH tu, awak bayangkan, Kenapa dia boleh jadi branch? Sebab tepi pun dia boleh ada SIO, bawah pun boleh SIO. So once again, cuba pause and cuba buat ni. Okay? Try buat macam mana daripada SI. Aduh, kenapa buruk sangat. Plus water. Okay? Kita boleh dapat SiOH, OH, OH plus R. Dia memang akan ada R sebab dia organosilicon dia tak boleh lah semua OH atau semua X. Itu dah jadi silicon halide. Okay, so dia memang it starts with the organosilicon. So cubalah dapat macam ni kita boleh dapat branches. So make sure you practice. Always first start with hydrolysis followed by condensation. Nanti bila kita tengok passing question pun it is a very popular one. Okay, make sure you try it on your own. Tak faham tak apa, in the next class ke apa saya boleh tunjuk kat awak. Okay? Okay, so let's look at some properties of silicon. So silicon, it is thermally stable up to 500 to 600 degrees Celsius. So around 227 to 337. And dia ada low viscosity. Maknanya kelikatan dia viscosity dia rendah. Okay, so which changes with temperature. So contohnya temperature tinggi, dia mungkin akan likat lebih sikit, kurang sikit, dia boleh tukar-tukar. Dia boleh dan dia boleh berubah, which is why silicon rubbers remain elastic even at low temperature. Okay, maknanya dia elastic bila dia tu. Okay, so kenapa saya letak kat sini? Kalau awak tahu all those baking tools yang kan, kenapa dia elastic semua walaupun high temperature boleh balik pada tu, sebab dia adalah silikon. So the presence of the alkyl group, dia kan sentiasa ada alkyl group kan, makes the silicon water repellent and hydrophobic, which is why bila awak bake benda pun dia tak melekat-lekat, awak masak benda dia tak melekat-lekat. And it is innate towards chemical attack or oxidation, which is make it very stable. Hence, dia ada banyak kegunaan. So, antaranya ialah it can be used as lubricant. So, dia bukannya dalam bentuk tu, it is a linear change polydimethyl silicene, known as PDMS. Okay, maknanya dia digabungkan dengan benda lain untuk jadi lubricant. So, it is also used as a low temperature hydraulic fluids. Okay, it's a linear change PDMS. And yang ni antara benda yang saya favorite saya sebab I like makeup. I don't really use primer. So sebab dia licin and boleh gerak-gerak, kalau awak tahu primer, if any of you are familiar with makeup, so sebelum kita letak makeup, it's always good to put some cosmetic primer. So dalam dia ada silikon. Okay, so sebab dia akan licinkan muka and tutup lubang yang ada, so that bila kita letak makeup, cantik je muka kita. Another one yang sangat popular, which is the PDMS, a cross-link one, is used for breast implants sebab dia sangat tahan and sangat stable. The silicone wax is also put on the surface of a car for water repellent. Kalau awak nampak yang ada jual even kat Mr. DIY, those that you spray on top of your car. Sampai bila hujan, water tu tak melekat, awak punya visibility lagi tinggi. So that is also silicone. Okay, so ni saya nak mention sikit pasal perbezaan antara silicon, the element, silica SiO2 and silicone. Okay, so silicone is SiO(Si). Silica is SiO2. Silicon, the element is SiO. So kita cakap what are they? So silicon, the element, is the second most abundant element on earth after oxygen. While silica is the produced bila kita dapat silikon dengan oksigen lah, SiO2. Walaupun kita tahu sintesis dia bukan senang macam tu. While silicon yang kita baru belajar tadi ada beza E So janganlah dia punya elemen tak ada E Bila ni maknanya dia masuk dia ialah SiO(Si) punya link tu. It is produced within the reaction of silicon, oxygen, carbon and or hydrogen. Carbon tu is the organo part lah. So some of the properties of silicon, dia high melting point, boiling point, and dia punya rupa is very macam berkilat-kilat, bluish grey metal. So silica is high purity, highly resistant and high transparency. Dia biasanya tak ada warna. Okay, macam silica gel yang tak basah, dia tak ada warna. While silicon has high thermal resistance, sebab tu dia boleh digunakan untuk baking and masak. Okay, electric insulation properties, and it can come in either solid, liquid or gel, bergantung pada bentuk yang kita buat dan suhu. So silikon antara yang paling dia punya tu kita guna ialah is a semiconductor. So semiconductor, kita sebut je semiconductor, orang akan terus fikir pasal silikon, which is used in computer circuits and other electronics. While silica ada guna dalam glass, ceramics, optical fiber and desiccants. Okay, desiccant yang kita guna yang saya sebut tu untuk serap air. While silikon dia banyak kita guna untuk cake molds, untuk baking, untuk cooking utensil, electric and insulation and adhesive. So itu beza antara tiga ni. Jangan tersalah bila kita cakap pasal elemen tak ada E kena ingat benda ni orang selalu salah buat. Okay, so let's look at the last compound before kita tengok some contoh of past year question. Halide. So for silicon halide, XiX4, all the halides exist, maknanya silicon tetafluoride, silicon tetachloride, silicon bromide, telabromide, and teriodide exist. Tapi yang kita lebih nak fokuskan is on chlorine and fluorine dia lah. Okay. So for chlorine, a series of chloride boleh. Maknanya bukan just SiCl4. Dia boleh berbagai-bagai jenis sampai Si6Cl14 boleh terbentuk. Okay. Dia just Si and N+2 for Cl dia. Okay. And all halides kecuali silicon tetafluoride are unstable and undergo hydrolysis in water. Bila dia undergo hydrolysis in water, kita eventually akan dapat silika dengan dia punya hydrogen halide. So contohnya, kalau it is a chloride, silicon tetachloride, eventually kita akan dapat silika and also the hydrochloric acid. For the case of silicon fluoride and tetafluoride, it only undergo partial hydrolysis. Why? Sebab F pegang Si tu kuat sampai dia tak senang lepaskan. So if you have silicon tetafluoride with water, kita akan dapat silika, tapi pun akan ada silika yang masih terikat dengan di fluorine. This is the hexafluorosilicic acid with hydrofluoric acid. So it's only partial hydrolysis. Dia tak sepenuhnya. So tadi kan dia cakap kan bila kita dapat the hydrolysis of silicon, the halides, kita akan dapat silika. So ini cara dia dapat, okay? It occurs through the formation of dative bonding of oxygen of water to Si of SiX4. So contohnya lah, kita ada water kan H2O2. So dia akan senang nak bagi attack the Si. So bila dia attack Si, bond elektron ni akan pergi kat sini and dia akan pair dengan H kat sini. So kita buang HX, kita akan dapat ni. So X tadi dia keluar, so dia dengan O. So OH ni dia akan bagi bond tu kat sini and X tu akan keluar supaya dia akan keluar as HX. So kita dah ada satu double bond. So another O akan bagi attack and the same thing happen sampailah kita eventually dapat SiO2. Okay? So cuba awak buat ni, tengok awak boleh berjaya dapat tak? Kita dapat SiO2. So dia lalu steps yang sama juga. Bila OH dah masuk kan? OH dah masuk kat sini, let's say ni dah tak ada, OH dah masuk kat sini. Once again, H ni akan bagi bond tu kat sini. Ini pun bagi kat sini. So keluarkan satu HX, baru dapatlah di SiO2. So apa tu dative bond? Saya just nak ingatkan, a dative bond is a covalent bond between two atoms where hanya satu atom saja will provide both electron that form the bond. Okay, so ini maksudnya the oxygen yang provide lah to this. Okay, just nak tunjuk macam mana kita boleh dapat SiO2. Okay, so itu sahaja 47 minit, a bit long. Okay, however you can break. So in between yang this one also I didn't put in a quiz, but I realise hari tu pun masa buat quiz itu ada ramai stress. Okay, my intention is not to make you stress or what, it's just to make sure you watch the video. Okay, tak adalah saya akan marah atau mengamuk, but I really hope that you can watch it during class time lah, because that's what class timetables are for, right? Okay, maybe after this I'll still put in a little bit of quiz it in between ke apa, but for this time tak ada. Just look at a few past year questions. So okay, silicon tetafluoride, chloride, hydrolyzed in wet water, forming a white solid. So dia just beritahu white solid je. The solid can be dissolved in hydrofluoric acid and sodium. So hampir semua benda silika punya compound macam ni. Identify the white solid and write the equation of silicon tetafluoride in, bukan air, ni bukan air, dia nak cakap air sebenarnya, in water. Wet air lah, water, and the dissolution of the white solid in both of this. So kalau white solid yang awak fikir tu dah salah, susah. So white solid yang dimasukkan sini is silika. So kalau awak dah salah daripada sini, so kita kena fikirlah apa yang white It's actually the silica is white in colour lah. Okay, silika memang biasanya in the form of powder white in colour. So kita kena first kita identify which is silica. Sini salah, tempat lain pun akan menjadi masalah. So kalau kita ingat, salah satu cara kita nak synthesize silica is by using silicon tetachloride dengan water, you will get the silica. Okay, and with a side product of hydrochloric acid. So kita boleh tengok dia punya proses. So tadi kan silika yang dia boleh larut dalam HF, kita akan dapat hexafluorosilicic acid with water, and dengan sodium hydroxide you will get water glass and also the water. So kena ingat sikit lah. Okay, well, the next one. So ini yang tadi yang silikon tu. Kita kan ada 3 jenis silikon kan. So dia suruh name the type of the silicon and this as the starting material, show how awak boleh dapat this type. So kat sini bezanya ialah tadi kita guna R dah. Tapi sekarang kat sini Dia dah letak R dia sama dengan CH3 dah. Okay. So, kita tengok sini dia ada 2. 2 ialah maknanya ada 2 O, maknanya tekanan. 2 O maknanya starting material dia kita boleh teka-teka is actually R2X. SiX2. So, bila 2 is actually chain silicon. So, chain silicon macam mana? Once again, kita kena buat lah. First, hydrolysis. Sentiasa kena ingat it always go through hydrolysis followed by condensation. Okay, so kita kena tulis proses dia, lukis keluar macam mana dapat. So, kalau daripada awal ni, awak tak lukis macam ni, hydrolysis, awak dah daripada awal, awak nak buat plus 2 water, awak nak terus dah lukis keluar pun boleh. Dia akan menyenangkan your punya condensation step. Kena tunjuk kena tunjuk water dikeluarkan, kena highlightkan mana water datang. Okay, sebab ada markah dia. Okay, so that is all untuk silicon. Okay, so I hope it's interesting because I think silicon pun banyak benda yang kita guna. Contohnya makeup, kita punya baking punya benda, and breast implant pun antara benda yang selalu orang dengar, breast implant silicon. That's actually benda yang we have been hearing about all this time. Contohnya silicon as in the element itself pun is a very important semiconductor. So I hope it's interesting enough. So like as usual, kalau ada soalan, please feel free to ask me. Kalau tanya soalan, I answer a bit late, sorry, and please remind me. In fact, I have 2 questions that I have yet to answer. I'll reply your message soon, okay? So just a reminder, this will be the last class before kita punya quiz. Test, bukan quiz, sorry. So our Sunday we won't have class because it's a public holiday and we won't do class ganti dulu. We will do later we see how. So I want you to focus on your test. So the test will be on 17th of May, Tuesday, week 9. So masa dia adalah kita akan buat dalam 1.5 jam. So from our class time 9 to 10:30 AM, and the location will be at C08 level 4 411. So I think most of you are not familiar with this. So kalau boleh pergi try dulu cari mana tempat tu, don't be late Okay, you have to be there at least 10 minutes before. So dia boleh duduk rearrange seat sikit. Okay, so try cari mana C08. Okay, so the topics will include 5 topik utama yang that we have learned. The organization of marine periodic table, bonding, hydrogen, group 1A and group 2A. So group 3 and group 4 yang kita belajar ni tak masuk. Okay, so thank you everyone for your attention this 50 plus minutes. Any question as usual, please ask me, and I hope you enjoyed learning about silicon. So the last part of group 4 will be on tin, stannum and also lead plumbum. Okay, so thank you everyone. Bye.